let me have some. There's a base diagram for our entire numerical. Okay, this will be 200 meter, 400. This will be 700 meter. 200, 400, 600. Okay, this distance will be 200 meter, 400 meter, 600 meter. It will start train traveling. It will enter with a uniform speed. So what is U equal to 72 kilometer per hour. If you convert this, it will become 20 meter per second. Okay, this will be, it will retard. It will enter here with a uniform speed. Train, I could not, okay, this will be, and it will accelerate. Finally, it will acquire the speed U. This interval of time, T1, T1, T2, T3, 400. Okay, all the data given. So what is asking? If they, and what is for one more information we have? If the time at constant low speed is equal to, okay, this is a given. We have to calculate the total time, T1 plus T2 plus T3. Hope, okay, there's all the data, what is given, I've just put it. We have to calculate this time. So what is capital T? Total time of journey. B square minus U square equal to 2 into alpha into 200. Okay, this will become equal to 400 alpha. I'm applying V square minus U square equal to A's formula for this. There's a one equation. Similarly, we'll apply equations of motion for this. U square minus V square. This is 2 minus alpha. So minus of 400 alpha. So this will become U square minus V square equal to 2 beta 600. Okay, this will become minus of, or 200 beta. Okay, equating these two. Equating 192. So we will get beta equal to 2 alpha by 7. Okay, no. So we'll do one thing. Okay, this is, so next again, T2 plus T1. Okay, what are the equations we can write further? T2 equal to T1 plus T3. So here I'll write some data. So it will move with a 400 by V. T1 equal to, let me write some equations. So with uniform speed equal to 400 by T2. V minus U equal to alpha T1. U minus V equal to alpha T1. U is equal to V plus beta T3. So therefore, substituting all this in the above equation, 400 by V equal to U minus V beta. Okay, there's a one primary equation. Let me have this in hand. Let me substitute this equation 4. Okay, now let me substitute 3 in 4. Put 3 and 4. Okay, this will become 400 by V is equal to U minus alpha. Alpha will be 7 beta by 2 plus U minus beta. What is U? U is in fact 400. So U minus V you can take common. U is, sorry, U is 20 we have here. So substituting this and solving, this will become 2 by 7 beta plus 1 by beta. Substituting U everything, solving this equation, I'll end up with equation 2800 beta is equal to 180 V minus 9 V square. This is the equation number 5. Okay, there's a one primary equation what we have. 1200. Okay, there's a one thing. So now let's apply the equations of motion for this. U square minus V square equal to alpha. Or we can apply for this. So it will be, sorry, this is beta, no? Symbol. Okay, now we'll apply this one. So this length is how much? 600 meter. Okay, let me assume that one. Let me write here now. So this will become U square minus V square equal to 2 beta 600. Okay, this will become 400 minus V square equal to 1200 beta. Equating these two, we'll get a quadratic equation. So 5 and 6. I have a place only here. I have to scribble here. So now equating 5 and 6. I'm giving all the equations number. So we'll end up with a quadratic equation solving for V that one. So or else we'll divide these two. So 2800 beta by 1200 beta equal to 180 V minus 9 V square by 400 minus V square. 28, okay, this will be 7 by 3 is equal to 180 V minus 9 V square by 400 minus V square. So 7 4 ja 28 100 minus 7 V square equal to 3 8 ja 24 54 540 V minus 27 V square. Solving this, 27 minus 7, 20 V square minus 540 V plus 2800 equal to 0. Solving this, we'll get expression for V. It's a quadratic equation. So let me further simplify. This will become 54, no? So 27 will come. 27V plus 140 equal to 0. V is equal to 27 plus or minus 27 whole square minus 4 into 1 into 140 divided by 2. Let's solve this. (27 into 27) 729. 729 4 into 140. 560 will come. $729 minus 560 will be 169. $27 minus plus or minus 13 by 2. So two values will come. 140. 40 will be 20. One will be 20. The other value will be or 14, 14, 7. Now, which one will prefer? Okay, this is not possible, no? This is possible because the initial velocity is how much is 20. The train will enter with 20 and it cannot final like a uniform velocity. It cannot. It has to retard. Okay, this is what possible. I think we had. I lost some connectivity. Okay, meanwhile I wrote it. I scribbled. So these are the equations. Applying the equations of motion. Yeah, complete description is there. Okay, first we'll apply the equations of motion. What is the T2, T2 equal T1 plus T3? Then total time of journey, sum of these two. Then what we do is like V equal to U minus AT formula, because the retardation V equal to U minus alpha T1. Then for this excited motion, U equal to V plus beta T3. Then for uniform velocity motion, the velocity is equal to distance covered by time taken 400 by T2. So therefore the T2 should be equal to 400 by V. T1 will be U minus V by alpha. T3 will be U minus V by beta. Then in this equation we have, so we'll substitute this alpha in this equation. Alpha, what we can write it as 7 beta by 2. Solving this, I will end up with an equation for beta and V square. How this beta and the acceleration and this V is what related. Let me apply equations of motion. U square minus V square equal to 2 beta 600. U square minus V square equal to 2 beta 600. Then solving this equation, now I'll get some relationship between, so these two equations. So what I'll do is like, let me eliminate the beta. I'll divide these two equations. Then I'll get a quadratic equation for V. Solving that V, I'll end up with 20 or 7 meter per. 20 is not possible because like it is initial velocity is how much? The initial velocity of the train itself is 20. How due to retardation this can be 20? So this is not possible. So 7 meter is what possible. That's what we'll take it here. Okay, rest all, let's get into this one. Already I wrote it. V equal to U plus AT. The value of T1, T2, T3, we have wrote it here. Similarly, we'll calculate this alpha because now we know UV and we know S1. I'm going to calculate the retardation alpha. Similarly, the acceleration beta will calculate. Then I'll substitute in this formula T1.